Okay, tomorrow's your test on the second part. Write down the formulas from the top, please. Okay, now, let's pick one that looks similar to the one you saw on your take-home quiz.
Oh, 46.
Oh, the 46, that's great. We're not going to do 49 because that's a little bit above what you're going to be asked to do. All right, so first term is -4. It's recursive, so you're going to throw that answer back up into the recursive part of the formula. So -3 times -4 is 12, -5 is 7. And the next term, you're going to put that answer into the recursive part of the formula. So -3 times 7, -21, -5 is -26. And then you're going to put that into the formula. 78 minus 5 is 73. And that's it. Easy breezy.
You lost me.
Where do you see 46? Are you kidding me? Going next. Get the first 4 terms of the explicit sequence. These are easier, really. You're plugging in 1, then you're going to plug in 2, then you're going to plug in 3, then you're going to plug in 4. It's just plug and chug. So which one do we want to do? Go crazy. Which one?
14.
14. Looks good. So we're going to do 3 times 1 over 1 squared plus 1. So the top is 3, the bottom is 2. Then I'm going to put 3 times 2, 2 squared, plus 1. So up top we have 6, and on the bottom we have 5. 3 times 3, 3 squared, plus 1. So we have 9 over 10. And you just keep going like that. 3 times 4, 4 squared plus 1, 12 over 17.
Can you explain 20 and 22? Just like for...
You mean with factorial for them?
Yeah, like how...
So are you asking me to do a second question?
Mm-hmm.
Okay,
Yeah.
which one do you want? 20 or 21? Or 21 or 22? Pick one.
Well, 20 is confusing like 22.
20 is just a straight, it's going to be -0.4 for all terms.
Okay.
Because there's no variable, it doesn't change, it's a constant. Okay. 21, 22, I don't know, let's pick 21. Okay. Second question. So you're going to do -1 to the first over 1 factorial. Well, that's just -1 over 1, so it's -1. Remember, when you have the -1 to a power, that's just going to make your terms alternate, positive, negative, positive, negative. Because now we have an even exponent, so that's going to become a positive 1. 2 factorial is 2, so that's 1/2. Okay? So -1 now to the third power is a -1 again, and the bottom is going to be what? 6, right? Because 1 times 2 times 3. And then -1 to the fourth over 4 factorial. Now we're back to positive, and that is 24. Okay? So you're literally just plugging in the answers. Or the terms, 1, 2, 4.
And then we're...
N over n factorial. Well, what is n over n factorial? So we cancel out the first n, so it's actually 1 over n minus 1 factorial. But you just kind of plug it in there. Yep. Okay? Here we go. Find the general term. So if you remember on your take-home quiz, there was 3 or 4 of these. So let's pick 3. Let's pick 1. Let's start with 1. from the top area somewhere. What do you think?
25.
25. What?
25.
29, sorry. Okay, so what I would do is I would say, is it arithmetic? Are we adding by the same amount? No. Okay. Don't charge for choices.
Well, Cam, if you think it's so easy, why don't you go up to the board and do it?
Literally 1 over n plus 1.
True fact. True fact. But what we're looking, is it arithmetic? It's not arithmetic. Is it geometric? Or are we multiplying by the same? No, we're not. So if it's neither of those, you want to look and say, all right, let's put our numbers, our n values up here, and say, how does that relate to those? So you've got a 1 up top, and on the bottom you have an n plus 1. Because the bottom is 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. So that's your general form. So it's not arithmetic, nor is it geometric. So you got to go pattern. Okay. How about another one? I'm sorry? 29 on the bottom. That looks scary, doesn't it?
Very much so.
But it's so easy.
It's E, comma, n plus 3.
So
There's one on the other one. Bottom left. Right.
this one? Okay, which one are we doing?
That one. Everyone will most likely be on the test. 3, 9. And that just be E, comma, 3, 9. Like 3 times, or 3 times n, sorry. E, comma, 3 times n.
29?
Yeah.
Well, if I do E plus, you mean? 3
Well, it's like the same comma.
Well,
Yeah, why is
okay.
there a comma there?
Here's the sequence, guys. E is the first term. 3 plus E is the second term. 6 plus E is the third term. So let's look at that sequence, shall we? So these.
No.
Here's my question. Is it arithmetic? Are we adding the same each time?
Yes. No.
Aren't we adding 3 to each one?
Yeah, you're adding.
Yeah.
So 3 plus.
So we can do it arithmetic. Arithmetic sequence is this guy.
Oh no.
All right. So our first term is
E.
E. So we have E plus 3n minus 3. That would be your sequence. It's arithmetic. You're adding the same each time. You can just put it in that formula.
So can adding the same each time is arithmetic even you're not?
And when you're multiplying each time, it's geometric. If it's neither, then it's straight up pattern. All right? Okay. So again, that one's not crazy hard. You just got to look and see what you're doing. Okay, what's the other one you guys want to do? This one? This 29? There you go. So, is it adding by the same amount? No.
No.
Is it, think about it this way, is it multiplying by the same amount?
Yeah.
The top is multiplying by 2 and the bottom is multiplying by 3. So I think our R value is 2/3. Right? You can see that pattern? All right. So the geometric sequence is first term times the R to the n minus 1, and that's all you have to write. So look, if they're fractions and you see a pattern that's multiplying top and multiplying bottom, that's going to be your R value. Okay. Or you can divide. Second term divide by first term, third term divide by second, whatever. Avish? Okay. Ready to click? I would make sure I would get online and practice a few more of those. Who is staying after school today?
Oh, no.
What? I can. What time?
After school. Review.
2:30 guys?
Well, give me a minute to breathe, but yeah. Maybe 2:45, 3 o'clock. Moving on.
6, 235, and 3.
Remember, if you have practice or something, you can look, that's what I'm saying, the problems will be online, so try it. Alright, here we go. Simplify the factorial expression. Go big.
We're going big. 64.
64. So, you're going to rewrite this so that you're expanding one of the factorials. Which one's bigger, the top or bottom? Top. So expand the bigger one. So 2n plus 1, and then you're going to subtract 1 from that. It would be 2n. And then I'm going to subtract 1 from that, and you'd be 2n minus 1. And as soon as it hits the denominator, you stop. Because our goal here is to be able to cancel. And then you just distribute or whatever you got to do. So 4n squared plus 2n is what it simplifies to. So you're expanding either the numerator or denominator. Which one's bigger? If the denominator is bigger, you're going to have 1 over something. Okay? Same deal though. You expand until you get to the denominator or numerator. Cancel out. Got it? Alrighty. Okay, find the sum and the terms of the summation. So how we're going to do this, just to alleviate you guys trying to figure out which equation to use, just find the terms. So pick one of these.
Whichever one almost like the
I don't know.
74.
You wrote the test.
I really didn't write the test.
And what?
This is McDonald. You know what? I saw it first this morning. That's the first time I've seen it. These are all pretty good questions. So you have to find the terms of the sequence 2 through 4. So we're going to plug in a 2. And we're going to plug in a 3. And we're going to plug in a 4. And we're going to add all those up. So negative 1 to the third is negative 1 times 2 is negative 2. Negative 1 to the fourth is a positive 1 times 3 is 3. Negative 4 to the fifth is negative 1 times 4 is negative 4. And you just add them up. So I have negative 3. That's what the sum equals. And these are your terms. So you want to see those terms listed, so make sure you're writing them down. And all you're doing is evaluating. You're finding so many terms, and then add them up.
Is this calculator tomorrow?
It's baby red calculator.
Baby red.
No big boy.
Why not?
Because you just pop that in your calculator with a button. And a third grader could
But
do
that's
it.
a good like.
Shouldn't we hold you a little bit higher standard than a third grader?
Well, like I would have. You should make the test so like you get points for showing your work, and if you don't show your work. Then...
No. Okay, ready? I'm going to just give you guys a partner test.
I'm going to have a calculator in the real world.
True.
Yeah.
But you won't be doing this stuff in the real world.
That's true. Why don't they make us learn this?
Moving on.
Oh, no, you're paying thousands.
Find the general term, ace of n. Given two terms in arithmetic sequence. Now, we did this in class with systems. Did we do it the easier way? Did we show you a second way?
You showed it, but
Okay, let's do it the easier way, because who would do systems? Nobody. So, pick one. Doesn't matter.
34.
34. So, we talked about arithmetic sequences being the same as what kind of functions? Lines, right? So we have technically in front of us 2 points. When n equals 5, ace of n equals 12. We did this then? When n equals 18, our sequence equals -1. So we have 2 points. We're going to find the slope. We're going to write a line of equation, a linear equation. So our slope, -1 minus 12, 18 minus 5. So that's our slope, or our common difference, the d value. Same thing. and then we're going to find a line from that. Pick whichever point you want. I don't care if you do point slope form, like we did beginning of the year, or maybe you plug it into y equals mx plus b. However you write your line. You do you. I'm going to do this one. I'm picking the first point. So y minus 12 equals my slope times x minus 5. That's my linear equation. So if I want to write it as a sequence, now it's a sequence. It's much easier than doing it with the systems. Finding A and finding the D for is just a mess. Okay? And same thing, if you like to plug in the y and the x into y equals mx plus b and you solve for b, whatever. Okay? You ready? Find the first sum, or find the sum of the first so many terms. So which one do you want to do?
47.
47. Guys, it does not matter. These are all what type of sequences?
Finite.
They are. They're giving you so many terms, so it's a finite.
Oh.
But
Arithmetic.
they're arithmetic. They're adding or subtracting by a certain number. Yes?
Yeah.
So we're going to use the arithmetic summation. I think that's how the formula is written, right? All right. So in the first one, they're telling you have 50 terms times, my first term is 2 plus, I don't know my last term. So I have to go to the explicit form of the sequence and start writing it out. First term plus, what's my common difference? 5 times, the n is 50, because I'm looking for that 50th term. I'm looking for a sub. So we're using our handy dandy calculators.
Big yellow.
I'm using my big yellow because I'm not going to cheat and put it in a little sequence thing.
We would have needed it.
Yeah.
Yes, you
I
would.
can't believe you think that way.
Don't even go there.
All of a sudden, I'm a calculator. Sorry. Shooting too high.
All right, so you just put it in formula. You have to find that last term. You find that last term by doing the arithmetic explicit formula. Okay? So you can use two formulas in that. Okay? 17 is find the sum of an infinite geometric sequence. So they're not telling you the first 10 terms or the first 50 terms. They're saying, give me all of them. Add them all up. And remember, this formula only works if you are decreasing. It's got to be a decaying type of sequence. Bouncing. Low, 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 low. All right? So pick one. 71. What is the R value? What are we multiplying by?
1/3.
1/3. So this is a really, really, really easy formula. It's the first term over 1 minus R. So the first term is 1/3 over 1 minus 1/3.
Is that an A1?
G sub 1, I'm sorry. In our old book, there was always geometrics for G subs and arithmetic for A subs, and that's how I just always put it. Right? So it doesn't matter if it's an A or a G. I can make it an R, or an S, or a T, maybe an M. All right, does that make sense? And you can put that in a fraction in your calculator. That's what I got to do. That's the easiest formula on the test. First term over 1 minus R.
I think that's all for old test.
I'm going to make 16 questions just like that.
That's 50.
Yeah, just like this one. Moving on. Find n given a sub n and a geometric sequence. So they're giving you a geometric sequence. So that's our geometric sequence. And they want you to find the value of n. So, which one do you want to do? 3. So A sub n or G sub n, doesn't matter, is this guy over here by himself, equals the first term times, what is my ratio? What am I multiplying by there? Yeah, negative 1/2, right? If you're not sure of your ratio, you can always take the second term divided by the first. They're telling you it's geometric. So it's the second term divided by the first. So it's negative 1/2. You have to get the base by itself, so you're going to divide by 1. Does that change anything? No, we're dividing by 1 here. So here's where we start. Now, if I try to do this using logs, I'm going to run into a problem because you cannot take the log of a negative base. Log is negative 1/2 doesn't work. So ignore the 1/2 or ignore the negative. Okay? I personally would just do this. This has got to be a power of 2. 4,096 is what? Power of 2. 2 raised to, give me a number, what do you think? 12? What do you think? Oh no, what is it? 2 to the 12. Very good.
We got a math god back here.
Yeah, exactly. So ignore the fact that it's negative. What's making it negative? It's bouncing back and forth, right? So what does n equal? 13. Right? Because our bases are the same, just like we did last chapter. The bases are the same. We have that little 12 equals n minus 1 exponent equation to solve, right?
Oh.
Easy breezy, lemon squeezy.
How did you figure
We are
it
done.
out?
Woo! What do you mean, how to figure it out?
How did no one figure it out?
Almost.
She's no
You just do
going.
guessing
We
check.
definitely have that.
2 to the 10th, I know, is 1,024.
And
So you double that, then double it again, so you got to 12.
the
All right. We are done.
Oh, yeah.